Hello, my name is Ralf Gerlich from the German software technology company BSSE. And if you have a pile of textual requirements documents for software laying around and wonder how you could turn those into formalized models, for example, for automated testing, then you're asking the same questions as we are. And maybe this presentation is for you. ExANT is a project that is being done with set of German institutions, and so ExANT is a German acronym. But let's suffice it to say that the goal of ExANT is to improve natural language requirements, transform them into formalized models using natural language processing, and then use those formalized models to do automated software engineering with them. And that is actually one of the reasons why you would like to formalize requirements in the first place. The formalized models allow their use in automation, such as code generation or testing. Those may be different kinds of models, but still they have to be rooted in the requirements. And in other domains, such as in manufacturing, this is already done in a way. A process called computer-aided design leads to computer models of the products, and a process called computer-aided manufacturing transforms those models into instructions for the manufacturing machinery. Also, it has been found that formalization helps with finding defects in requirements. For example, the maths activity done for ESTEC in 2015 by Airbus and DNV has shown that the process of formalization alone leads to the detection of many defects and ambiguities in the requirements and to fixing them. And that, of course, is interesting because ambiguous requirements lead to costly discussions. In the worst case, you'll have that discussion at the end of your project when you're trying to deliver your software to your customer, and your customer disagrees regarding the interpretation of some very important requirements. And you might have to start over. So if it's so advantageous to formalize your requirements, why isn't it been done already? First of all, these formalized models are kind of an acquired taste. Not everybody likes working with those, and also the number of experts compared to the number of software engineers is small. So it requires specific knowledge and also some kind of a very specific temper to like working with those. So transforming requirements documents, text-based requirements documents into formalized models is actually tedious, and it is costly when done manually. It takes a lot of time, and you're not able to just translate a single requirement into a single line of your formalized model, but instead you have to consider whole sets of requirements and transform them into whole sets of specification elements. So there have been steps towards formalization in a way. For example, there have been proposed specification templates where you kind of have a text where you have to fill in the blanks with the specifics of your specific requirement. So that gives the requirements some kind of form already. Also, there's the INCOC guidelines that guide you in the formalization and in the formulation of requirements in the first place. And there's also tool support for these in the form of, for example, the IBM Requirements Assistant or QV Scribe that actually look on the content. However, the principle, the specification templates and the general guidelines are for manual application only. You have to sit there and do it on your own. There's not much tool support for providing you with inputs on the quality of your requirements in your domain. There's no domain-specific support. These are general software or even general engineering principles that are applied here. And we all know that depending on the domain you're working in, there may be domain-specific knowledge that you require in order to provide proper requirements. And also, while this is all nice and good, it still doesn't provide us with models that we can use for automation. So what we want to try at least is to use AI to bridge the gap. The basic principle here would be that we have our initial textual requirements and we send them to a quality analysis using natural language processing, or short NLP. Based on the reports that we get from such a quality analysis, we would have improved textual requirements, and we could do this loop for several times until we're satisfied. Note that this kind of quality analysis with natural language processing is already being done, for example, with IBM Watson. So it's not just a completely new thing. There's already some kind of experience there, and we want to build upon that experience. Once we are satisfied with our improved textual requirements, we would then extract a specific model for our specific use from it. And that would be in a formalized notation, giving us all the information in computer accessible form that we need to perform our tasks, such as code generation or test generation. We, the team, is a team of 4 institutions and companies from all over Germany. I will briefly introduce them in alphabetical order. So first in the alphabet is BSSE, the company I'm working for. We are located in the southwest of Germany near the Lake of Constance. We are the coordinator in this project, and we bring in our experience in automated software development, both in code generation and automated testing. And automated testing will also be what we want to do with the final formalized models. So we will represent that use case. Then there is the Institute of Space Systems of the University of Stuttgart, who bring in their experience in spacecraft and the software development process. And they will apply IBM Watson Studio. So that is one of the tools that we will consider in this exercise. Finally, they will disseminate the results via their venue of education at the university to bachelor and master students and to PhD students. Then there's OHB Digital Services, located in Bremen. They are experts for natural language processing and artificial intelligence processes. They are also familiar with several NLP solutions, including open source frameworks that implement these solutions, such as Spatie or the Hugging Face transformers. And they will provide that input to the whole team, that experience. And last but not least, there's OHB System, located both in Bremen and in Oberpfaffenhofen. And as a large systems integrator, they have a lot of experience with both writing and interpreting requirements documents, specifically writing and implementing software requirements documents. So they will provide anonymized requirements from actual projects here. So we're not dealing in fantasy requirements here. We're working with real requirements from real projects there. And they will also be consulting us on requirements engineering with their experience. And finally, they will be users of the results, both in terms of the improvement of requirements as well as the possible outcomes in terms of automated software testing. So let's get back into NLP, or natural language processing. Natural language processing is the concept of giving a text or piece of a text that is expressed in natural language to a computer in order to extract information from it. So natural language means that there's not even some implicit formal syntax or semantics behind it, but instead usually the structure, the syntax, and part of the semantics are learned from actual natural language experience. So we are in the domain of machine learning here. One of the things that NLP can do for us is dependency parsing. If we look at this example requirement, the GPS monitor shall set its validity flag to false if the spacecraft is executing mode 4. Then first of all, we notice that mode 4 is not a sensible name for a mode, for an AUCS mode or any other mode on board of a spacecraft. This is because these are actually already anonymized requirements examples that we have used for the initial discussions. We can, using dependency parsing, we can identify the major parts of this sentence and their relationship to the other parts. So for example, we will identify set as the verb in this sentence, and GPS monitor is the associated noun. Another associated noun is the validity flag, for example. And you see that this is not quite perfect yet. There still needs to be some training to be done, which is also part of the activity. Another thing that NLP can do for us is the recognition of named entities. Specifically also if there are different formulations of the same name used for referring to the same object. The other aspect is the identification of spans with a specific semantic meaning behind them in the sentence. So again, we have that sentence from before, and here we can, for example, identify the spans that represent the subject or the action or the condition. And in this case, this has already been defined specifically for what we intend to do. This can even be broken down further. So for example, we can break down the action into the activity, which is set, the data item, which is what is to be set, and the assignment, which is the value which it is to be set to. Finally, there's one very powerful tool available in natural language processing, and that is question answering. Again, looking at this requirement, we could ask, what is the aim? The aim is to set the validity flag of something to false if the spacecraft is executing mode 4. Now we can ask about further details. So who is doing that? What element is doing that? Well, the GPS monitor would be doing that. And what is needed for this to be done? Well, the condition that the spacecraft is executing mode 4 needs to be fulfilled. Although this is quite a simple model, this example here, this concept is very powerful for extracting information from text. And then there's also classification. If we want to look into the requirements and sort them into different types of requirements in order to have them together, we can do that using multi-class classification. For example, this requirement could be a functional, an interface, or a performance requirement. And when we ask the NLP processor which one of those it is, it would answer us that it is a functional requirement. Now, AI models need to be trained. Essentially, they are a fit to some predefined function. And that function is defined in terms of training data. And the nice thing about these natural language processing models is that they can be built hierarchically in kind of a process pipeline. So in a first step, you could generically split up sentences into their parts. And that structure can already be learned from generic texts. In case of the available models that we will be using, some of them, for example, have been trained on the texts in the English Wikipedia. So they have learned the basic structure of English language from a huge set of English texts. And this is done by so-called semi-supervised training. So part of the training is done in a supervised manner where we have labeled data. So we have sentences where the relevant parts are marked appropriately. And then there's parts where the training is done unsupervised. So the network, the AI, tries to identify relevant structures from abstracting from the whole data set, and then it identifies these structures using our labeling of them. There's several options available for doing that, and we will be looking at both open source and commercial options such as Spacie and Hugging Face transformers on the open source side, and IBM Watson natural language understanding on the commercial side. And what we will have to deal with is probably interpretation issues. So these are the issues of ambiguity in natural language. Let's again look at this requirement. It's a different requirement this time, and it's also not necessarily one of the best expressed requirements. But let's look at it. It says, set the validity flag for the GPS monitor to true if the corresponding GPS unit is active and the AOCS mode is mode 1, mode 2, or mode 3. Now let's look at another one that we've already seen in similar form. Here it says, set the validity flag for the GPS monitor to false if the spacecraft is executing mode 4. And already from cursorily reading this, it is clear that this refers to the same concept. The validity flag is obviously the same thing. But this is expressed for different cases. So some of the questions that we might ask is whether the corresponding GPS unit is actually the spacecraft. Because we are referring to some modes here, and we are also referring to a mode in the other one, but we're referring to modes of things that are expressed differently. So this is one of the questions that we have to answer when we want to formalize this requirement. Another question is whether these modes are actually part of the same enumeration, or all of these AOCS modes. In the first requirement, it's quite explicit. In the second requirement, it's not that clear, but we might have to collect all of the modes that are possible and associate them with the proper element in the software. And also, we could ask whether is executing actually means the same as the AOCS mode is in this context. So here we see there are some ambiguities that may have to be resolved before properly processing these requirements in formalized form. And as I've said, the requirements that we've seen so far in the slide before are not that well expressed. And that is part of the improvement loop that we have in the beginning. So the initial impromptu formulation might be set the validity flag for the GPS monitor to false if the spacecraft is executing mode 4. And the first thing that you might see is that the typical shell form that you have for textual requirements is not being used. And so this might be something that we want to change in the first place in order to express the urgency of fulfilling this requirement. However, now we're still not clear about who has to do that. Which element of our software is responsible for doing that? So it's a passive notation. And so we would want to change that into an active notation using the shell expression. And here we have the actor specified. And as you may notice, identifying the actor as being the GPS monitor is not something that is clear from the text in the beginning. So it needs some engineering knowledge, and that is why this is a partially manual process, at least this improvement. The extraction might be possible to be done automatically then. And here the idea of automated testing is to use that process, and the result of it being a formalized notation, we can use that to create test oracles, and these can in turn be used to generate test sequences. Of course, test oracles are just a specific form of test model, and we could use any form of test model, for example, even sequence-based specifications, as it has been done in MATS. In order to not overload ourselves too much, because the question of formalizing requirements is already a very big one, we have also limited the scope of the requirements that we will be looking at. ECSS knows these types of requirements, and we limit ourselves to functional, performance, and interface requirements so far. And we want to focus on the space domain here, so we want to have all that domain-specific knowledge and see where it can be applied and where it can be of use in this whole process. So the plan is the following. The kickoff was in December 2021, and finalization shall be in November 2023. So there's 2 years. And so far we are here. We're in the process of setting up, getting to know the tools, getting to know the methods, and now we have also established our set of requirements that we can use for training and evaluation. So there's not much I can tell you about the results yet. We're still in the beginning, but I would be interested in your feedback on what you think about the idea and maybe what we should look into in detail. So thank you for your attention, and I will be happy to take your questions.